Today we're going to solve a GRE problem where we have to compare two quantities, A and B, given the information in the problem description. First thing we're going to notice is that our variable A is negative, so it's smaller than 0, but it's greater than -1, and our variable B is greater than 0, but smaller than 1. Additionally, we know that the absolute value of A is smaller than B. But this doesn't let us directly determine whether quantity A is larger or smaller than B. What we have to do is actually simplify each of those quantities to have an easier form to work with. So for quantity A, we're going to simplify it as follows. So quantity A squared times square root of B divided by square root of A raised to the power of 2. This equals A to the power of 4 times B divided by A. And here we have, we can simplify it to get A to the power of 3 times B. And then for quantity B, we have A times B to the power of 5 divided by square root of B raised to the power of 4. It's important to know that square root of B actually equals B to the power of 1/2. And then when we raise it to the power of 4, we're going to multiply those two powers, and we're going to get B to the power of 2. Then we can further simplify this and get A times B to the power of 3. And at this point, it's probably good to check whether maybe one of those quantities is positive and one negative, because that would let you directly get the solution of the problem. So let's take a look at quantity A. Here we have A to the power of 3, which is a negative value because A is negative. A raised to any odd power, like 3, will remain negative, and B is always positive no matter what. So this is negative number multiplied by positive number, which is smaller than 0. And here, the same thing. A is negative, B raised to any power, like 3, will remain positive. So you're going to get two numbers smaller than 0. So we have to further work with those numbers to determine the solution. And I'm going to write them out next to each other, and let's see whether we can see any similarities between them. So we're going to compare A to the power of 3 times B and A times B to the power of 3. This represents we're going to put some inequality sign there once we know it, but at this point we don't know it, so it's a question mark. But we know that this is going to be some inequality, and we can multiply or divide inequalities. And in this case, I would like to divide by B to further simplify. So I'm going to get A to the power of 3, and it's again in some kind of relationship to A times B squared. And I know this is the same relationship because B is positive. So when we multiply by a positive number, nothing happens to the inequality. But there is one important rule that we have to apply right now. Because when we multiply an inequality by a negative number, the sign of the inequality reverses. And this is the key here. Because what I would like to do is I would like to divide by A, but A is negative. So actually what's going to happen is after I divide by A, the inequality sign will reverse. So here is reverse. All right, so we're going to have A squared, and here we're going to have the reverse equality is with some kind of relationship to B squared. And now we're actually able to go back to our star here and figure out what this relationship is. We can actually take the relationship between A and B given in the problem and raise it to the power of 2. So we're going to have this, and we're going to raise it to the power of 2. A good thing about absolute values, when you raise them to even powers, they disappear. So you have A to the power of 2 is smaller than B squared. And now this allows us to put the inequality here, right? And now we're going to go back, right, and say, okay, what do we do to get from here to here? We actually reverse the inequality sign. So instead of writing that A to the third is smaller than AB squared, we're going to write that it's larger than AB squared. And here we only divided by B, so nothing happens, and we are confident that this is the right sign, making this our solution, so A is greater than B in our quantity.